Hello friends, continuing with the topic of electrical capacitance. Today we derive the expression for capacity of a parallel plate capacitor, which is given by the expression C is equal to epsilon 0 A by D, where A is area of each plate and D is separation between the plates. Now, physical situation. Consider a parallel plate capacitor having A as the area of each plate and D as the separation between the plates as shown in diagram. Let the capacitor be connected to a battery of PD. PD means potential difference, V volts. So this is V volt battery and gets charged. I repeat, let the capacitor be connected to a battery of potential difference V volts and gets charged. Let the charge stored be Q. Here Q. If C be the capacity of the capacitor, then C will be equal to Q by V. From the basic definition of capacity, we have this expression for C, the ratio of charge stored to potential difference developed across the capacitor. That is called as capacity. So therefore C is equal to Q by V. Let us mark it as equation 1. Now, but V is equal to E into D. That we know already, that relationship between potential difference and electric field is given by the expression V is equal to E into R, where R is the distance. So here separate this distance between the plates is D, and E, if E is the electric field developed inside the plates, then potential difference V will be equal to E into D. Let us mark it as equation 2. Now substituting the value of V from equation 2 in equation 1, we get C is equal to Q divided by ED. Let us mark it as equation 3. But E is equal to sigma by epsilon naught. Electric field between the plates is sigma by epsilon naught. Let us mark it as equation 4. Now substituting the value of E from equation 4 in equation 3, we get C equal to Q divided by sigma by epsilon naught into D, or it is equal to epsilon 0 into Q divided by sigma D, or it is equal to epsilon 0 Q divided by Q by A into D, because sigma is equal to Q by A, or finally it is equal to epsilon 0 A by D, because Q will cancel, we are left with epsilon 0 A by D. So therefore capacity of parallel plate capacitor is given by the expression epsilon 0 A by D. Let us mark it as equation 5. Now, factors affecting capacity of parallel plate capacitor. The equation 5 reveals that capacity depends upon 3 factors. One is area of each plate, second distance between the plates, third is medium between the plates. Now let us take up discussion. Since we know C is equal to epsilon 0 A by D, so first point we derive from this expression is that C is directly proportional to A. That is, capacity is directly proportional to area of each plate. If area of plates is doubled, C is doubled, and when area of each plate is halved, C becomes half. Second point, C is inversely proportional to separation between the plates. That is, C is inversely proportional to D, the separation between the plates. If distance between plates is doubled, C becomes half, and if distance between the plates is halved, then C becomes double. Now third point. When dielectric medium with absolute permittivity epsilon A is introduced between the plates, then capacity say Ca is equal to epsilon R C naught, because Ca is equal to epsilon A into A by D, but epsilon A is equal to epsilon R into epsilon naught, and it is equal to epsilon R into C naught, because C naught is equal to epsilon 0 A by D. Thus capacity increases by a factor equal to dielectric constant of the medium. Now we come across another definition of dielectric constant of a substance. Now since Ca is equal to epsilon R into C naught, therefore epsilon R can be expressed as Ca by C naught. Let us define now. The ratio of electrical capacitance with dielectric medium between the plates and electrical capacitance without dielectric medium between the plates of a capacitor is defined as dielectric constant of the medium or relative permittivity of the medium. I repeat, the ratio of electrical capacitance with dielectric medium between the plates and electrical capacitance without dielectric medium between the plates of a capacitor is defined as the dielectric constant of the medium or relative permittivity of the medium. Okay, this is a new definition of dielectric constant. Previously we had epsilon R is equal to epsilon A by epsilon naught. Then we have the epsilon R is equal to F naught by Fa. Then we had epsilon R is equal to E naught by E A, and now we have epsilon R is equal to Ca by C naught. Okay, so remember 4 alternative definitions of dielectric constants. So sometimes they may ask in any term, so you are to answer according to the term they have quoted. Now assignment 2.3 continued. Question number 5. Obtain an expression for capacity of a parallel plate capacitor. This is the article that you have learnt above. Question number 6. In a parallel plate capacitor, the capacitance increases from 4 microfarad to 80 microfarad on introducing a dielectric medium between the plates. Calculate dielectric constant of the medium. So use the formula Ca is equal to epsilon R into C naught. So epsilon R is equal to Ca by C naught. So it will be 80 by 4. So it will be 20. Question number 7. A parallel plate capacitor with air between the plates has a capacitance of 8 pF. What will be the capacitance if the distance between the plates is reduced by half and the space between the plates is filled with a substance of dielectric constant 6? Question number 8. Two circular metal plates, each of radius 10 cm, are kept parallel to each other at a distance of 1 mm. A. What kind of capacitor do they form? B. Mention one application of this capacitor. C. If the radius of each plate is increased by a factor √2 and their distance of separation decreased to half of its initial value, calculate the ratio of the capacitance in the two cases. D. Suggest any one possible method by which the capacitance in the second case can be increased by n times. So with this we come to the end of this part. Thank you so much. We will continue with this topic. Next time we'll take up third part of it.